get to meet him. Krzysztof Suchecki got his master's degree in Warsaw University of Technology in Poland in 2003. Then he worked for his PhD thesis there in the same place, but part of his thesis he spent several months here with us, working on vocal models and complex networks. And after his PhD in Warsaw, then he moved to a place called the right? The Virtual Knowledge Studio, yes, okay, of the Royal Academy of Arts and Science in the Erasmus University of Rotterdam in the Netherlands. Okay, we'll explain that. And during his postdoc there, that's what he was doing, and that's he will explain us today. And he will be here for us for some time, I suppose. So welcome.
Good afternoon, ladies and gentlemen. My name is Suchecki, and I'm going to talk today about what about the project I have been doing during my stay in Amsterdam. First, it was Virtual Knowledge Studio, but towards the end, it was reorganized into e-humanities group, and I was also affiliated with Erasmus University for formal reasons. And I had three colleagues in this project. Andrea Scharnost, she's most of the group is of this virtual university is not physicist. I was the only physicist there. Andrea Scharnost was responsible for modeling and things like that in the virtual knowledge studio. She has a physics background, but only a little. And Admila Agdak was art historian, and Chenga was a programmer. And we all worked in the project. And we worked in a knowledge space that does this KSL project. And the main premise of this project was to look into a structure of knowledge. As we know that knowledge will be organized and visualized in different ways. One of the ways are more traditional ways, like hierarchies that are thought up by somebody who thinks he knows everything and tries to organize knowledge in a specific way. And the other way is something some of us know, it's the networks when we look into relational information. So in our project, we wanted to see about what is the structure of knowledge. Of course, we only managed to take a little peek into the structure of knowledge. And for knowledge is very broad term, and for something to actually look into, we consider a Wikipedia as a body of knowledge. We also were at the beginning considering also looking into science and scientific papers, but that would be only a small part of the general knowledge, where Wikipedia is more broad than just science. So we have looked into Wikipedia. And of course, if we look at the Wikipedia, this is not our picture, but it's just to illustrate here that, as we know, if we just take the whole thing, we can't see anything. We don't see any structure except a big wall of links and nodes. So we have to do something about it. So, for the Wikipedia, what we have looked at is the links inside the Wikipedia. We considered direct links in the text, so all the reference that people doing the article make to other articles. And also we took into account the categories that the articles fall into. But we disregarded all other links that are actually in the Wikipedia page, like all external links, all the links that are in the templates or other things that don't really show the content of the article. And we ended up with a network of where we have categories. We have articles in the Wikipedia which belong to some categories, and the categories can also belong to other categories. So we further considered these links, we call page links between the articles, and these links, category links, so links that assign article or category into some other category. We completely disregarded other kinds of links to the other, to not category and not article page, like talk pages or portals or, like I said, external links. We throw away between two and that. So we have all the Wikipedia, links between articles and links to categories. And but if we just look, I chose the earlier part because then it's small enough network. But if you look at it, we still can't really see much. So to further look into the structure, we concentrate on categories. This is also categories of this in the Wikipedia. But we also compared the Wikipedia with a traditional classification scheme, namely universal decimal classification, which is a scheme used by some libraries to organize knowledge. But originally, UDC was devised not as just a library classification system, but as a system of organizing all knowledge. That was how it was devised in the beginning of 20th century. The UDC have two kinds of tables. It has a main table, which is a hierarchical tree detailing different topics, and auxiliary tables, which are supposed to support this table. But what we concentrated on is the main table. So we had just had a hierarchical tree. For example, like natural science, then physics and biology, and so on and so on. This is this hierarchical system that is UDC. On the other hand, we had our Wikipedia, where the categories are, which is not a tree or even hierarchical system. We can have multiple links and even loops, also of the length too, or larger. It happens. So how do we compare this, or how do we further look into this structure? We did hierarchize the category structure in Wikipedia. So if we have some structure, we define a root for our hierarchy. How we define this root, I will tell in a moment. And we looked the categories or articles that directly belong to the root by the category links. These are category links. are defined to be on the second layer, then next on the third layer, and so on. And later on, all the links that disagree with the hierarchy, for example, this link that was between two categories on the same level 2, were discarded. We do realize that this act influences the outcome quite a lot. If we did characterize differently, we would probably get different results, but we had to do something. Okay, this is one note about this characterization. This is shows the depth, and the depth, I mean, which means. Sorry.
Yes. How do you establish your root?
Okay. All right. In a moment. How I establish it? It's just next slide. I can just fast forward there and then I'll explain this later. But maybe it will. Okay. So for hierarchy root. This is just this graph is just shows the number of categories and category links. Basically, everything started here in 2004. It should be 31, not 30, but never mind. When the category system was actually, no, it's correct. Because everything started 2004. It was not June, but still May 31st, the end of May 2004. The category system was introduced, and the number of categories grew as the time goes. How we define these roots? We identified two roots during the whole time. It changed because it's all changing. We actually started at the end because when the system is quite developed, although it's still not perfect, it's never been perfect. In this time, we identified there is a category main topic classifications. This is not the very top category, which means if it was here, if this was our main topic classification, there would be something above it. But this something is not. It would be more like meta organizational levels because it was, for example, category contents, not category contents. This is the very top category in this moment, but it contains categories like articles or categories by name or Wikipedians, Wikipedia administration. It doesn't describe the topical content of the articles. Of course, the category main topic classifications is 2 levels below the contents, category contents. But it's, of course, it is in there. But we choose this as a main topical classification because it contains categories like biology, physics, people, earth, or something like that. So the categories that describe parts of the knowledge. This category was introduced in 2006 at this moment in main topic classifications. So before that we had to identify the equivalent of it, the best equivalent we could find, and through looking at the the network of categories around the main topic classifications just after it was created, and at its immediate neighbors, I mean immediate above and below categories at this moment. and looking how the network looked before introduction of main topic classification, we identified category fundamental as our main topical category. And this category appeared at this moment, but before that we could not find any main topical category. It was just almost pure chaos. I mean, there was practically no structure at this moment. Quite a lot of the categories were completely disconnected because they were. This is just half a month before the category fundamental was created. It was less than half a month. So before that, the system the people that actually were creating this classification, like everything in Wikipedia, didn't self-organize enough to actually have a top category. And later, the category fundamental was introduced and emerged as this main topical category that we identified. Does that answer the question?
Yeah, really. In a sense, I mean, you're transforming a network in a tree.
Not a tree. We are not transforming it into a tree. It's not exactly a tree. It's just hierarchical. There are no directed loops, but there could be multiple paths to the top. But your question is how do we choose that? Well, as I said, we choose that to be our topical category. And how did we find it? We didn't have any algorithm or something. We just had to decide somehow. And we just looked around what was the best candidate for that, and found those categories as our as best routes that we could find.
Okay, so you define the route as the best or the most suitable to be the route.
Yeah. Well,
and what specifications are considered to be suitable? Because
there
most of the links, it was created before, it was one of the first categories to be created on that, or it has many categories that depends on that one, or this is the fastest growing one. So what defines the route?
We didn't have a strict definition of that, but what our guidelines was that we wanted a category that's very high in the tree, so that above, if we look above it, the categories that are higher in our higher. I mean, if you look at the categories that, for example, category main topic classifications belong to some higher category, which belongs to the category contents, which is very top category. But as I said, the category above main topic classifications doesn't really contain topical categories. So we wanted to find the highest category that was that described the topic that divided the organized knowledge into topics, different topics, like for example, in main topic classifications there were, for example, it's not the whole list, but just a few of I think the top few of the categories that are in the main topic classifications just after it appeared. And for example, these are categories that were inside the category fundamental, which was in the categories that was very top around this time. But if we look at what categories contains, it's Wikipedia administration, portals, categories named after people, lists, categories by topic, which actually categories by topic doesn't, despite the name, does not really show the topical categories. So that's what we've thought. And here we have society structure, thought, nature, and information. It's not what think best, but all the science, for example, is under nature, or the scientific topics like physics, categories physics, biology, or something are under nature, for example. So this is a topical category that we choose. There were no hard defined rules how to find it. We just had to find it.
Then you use one before that date, and then this other one after that, or
Yes, yes. So we basically worked on a monthly snapshot. So this and everything before, we used category fundamental as a root, and at this and everything after, at the end, we used main topic classifications as our root.
And you see strong changes into the analysis?
Sorry?
You see strong changes into the results, of your analysis, or using this kind of doing this shift in the
Honestly, it's not that much noticeable because especially that some of the categories, for example, you see nature appears here and here, so it basically transfers some of this society also. Even I'm not sure about structure or information, but but some of them continue to exist in a tree defined by different root, but they continue to exist. So we believe this is quite reasonable because obviously before that point we made a classification didn't exist. Okay.
Krzysztof, the categories, who sets the categories and organization? Is this a committee in Wikipedia, or is it done as the Wikipedia itself? It's like everything else in Wikipedia. People can create categories. And, but I can decide what is in the main topic classification. I go there and say, well, for me a category there
it's a bit different because what is in the main topic classification means that these categories are categorized as this, so they have links to main topic category links to main topic classification. So for example, you could create an article that has direct link, the direct category link to main topic classifications. You could do that, but probably some of the Wikipedia people that society, there are lots of Wikipedians that just seem to or try to organize this thing. But they would probably say that you shouldn't link to this, put any article into this category, but you should find more suitable categories or something like that. But yes, it is possible to create, to put a category or article into any categories. There are no strict rules for that. I mean, it's of course there are people, like I said, there are people that sort of try to police the Wikipedia, but there were never rules for that either. How to police it. But we believe that the structure around the top, for example, the appearance of main topic classifications was sort of modeled after classical schemes of organizing knowledge. So the people that were actually working with these categories tried to model it so that it reflects the usual concept that, for example, we have physics, we have chemistry or something, or science in general, or some other broad categories, and they put it into main topic classifications. We don't know the exact specifics who created that category and why. We don't know that.
still should go ahead.
Okay, this is just to show that the growth of the category links and category pages were basically very tied to each other. But we could see also already here. These curves are basically the same. There's about like 19 category links per each category. But they grow simultaneously about the same rate. So we got this topical category, our root, and then directly below the root we have our top categories. We have root and our top categories. This is made root and top categories. And this we started analysis how large are those categories. So this shows the situation in 2008, and the size of each category reflects the number of articles that are there by fractional assignment. What does it mean by fractional assignment? It means that every article has weight 1, and then each article transfers its weight upwards through our hierarchy, splitting evenly amongst all the categories that belong to. So, for example, if it has only one link, it will push 1 here. If it has 2 links, it will push 1/2 here. Then famous sentences have 1/2, so and 2 links, so half here goes here, half goes here, and so on and so on. That's how we get the size of the categories, so the number of articles in them by fractional assignment. Why did we use fractional assignment? Because it's impossible to simply say that article is in some category, because obviously there is whole structure in between of different categories. But aside from, but that was not the only way how we looked into these categories. Because this is fine, but this also only allows us to see the size of the category. The second thing we did was try an ambiguous assignment, as I called it. There's one error, but I will. Each top category was assigned a weight 1 itself. I mean, each has a sort of vector, which with 1 in its own coordinates. So if we have 3 top categories, the vectors have 3 coordinates, and each one has 1. And then it was propagated downwards. So, but this time no splitting. So if politics has 1 here, then it transfers 1 downwards to each of its children categories, but other categories also contribute, and then it is normalized. So, for example, 1 from here, when it's half. And of course, for example, half is transferred down, and it's summed over all the contributions and normalized. And then we assigned, said that for example, this is in science because it has over 1/2 in science. Over 50%, it belongs in more than 50% to science. This is ambiguous. We don't. It's not clear where it belongs because it's half. But here it belongs to science because it's 1/4 and 1/4 of people and 3/4 of science. So it would be science. What the error I said this should be red because this is obviously equals to 1.
How is decide these weights?
The weights? Well, the top categories has
not the top.
like I said, for example, if you have people is the second.
But the lower layers, how are these weights defined? How do you obtain these weights? So this 35% famous scientist, 75% physics.
Okay, so
how you get this number?
No, it's not 75% physics. It's 75% science. First, the coordinates correspond to the top categories, not immediate categories above it. So this has 75 because it's half from famous scientists plus 1 from science from physics. So it's 0, 1 half, and 0, half, and 1 and half, and normalize this 0, 25, 75. We are propagating down from top categories the information that this belongs. So basically, these are fractions how much it belongs to different top categories.
But you have taken away all the links in the same level, no? If it's
Yes.
some politicians, they can be
Yes. As I said, the links in the same level are removed at the moment we create a hierarchy. That's why we have different levels, and we could say up or down the hierarchy. It's clearly defined.
And then when you count the number of links you count, are only the links which are at the bottom of the page in which there are states the category, or rather are all the links in the page?
What I'm here now talking about, this is category structure. These are all categories and articles that belong to a category. So this is all category links.
Only category?
Yes, this is all category links. I haven't got to the part where I'm actually using page links because we've focused on the category structure and later compare it with the link structure. So this is our another method of, and of course by this way we can also say how large is a category, because we can just count the number of articles that belong unambiguously to a given category. And this is just a comparison. The outer ring is the fractional assignment. The inner ring is by unambiguous assignment. The gray part here is ambiguous, articles. As you can see, of course, there are changes, but they are not that great. I mean, the same categories are still leading. Maybe not exactly. They're not. It's mostly the same category, so it corresponds slightly. Anyway, okay, this is just the number of categories at certain depth of the tree. It was to show that at the depth 5, well, actually it should be 4 because this should be 0 as a root. To show that the category tree is basically like it grows exponentially, so it's basically doesn't have any special topology. This we also look. This is related to the ambiguity. We looked at this vectors, not vectors, but at the fractions, and just calculated the simple Shannon entropy of this series to see overall how ambiguous were the categorization at a specific depth. So average entropy is here, and it's obviously increasing because as we go deeper and deeper, then more and more categories sort of interfere with each other. everything that belongs into one or second category will interfere the more down we go. This is just number of ambiguous, which means that it's clearly this was done a bit earlier than the unambiguous assignment by 1/2. So this is a bit more strict. This means that it's practically exactly one category. This is the fraction. This is just to show that this is the number. This is the number of the number of categories. So this is the evolution of the topical categories in Wikipedia. And this is by article weight, which means the size by fractional assignment of a number of articles. As we can see, there were for sometimes the structure is sort of stable because the sizes of the top categories remain constant, but obviously there are some drastic changes along the way, and about the moment when it was changed from between fundamental and main topic classifications, that was here. Where it differentiates into more categories. This moment is still with category fundamental, and this moment is with category main topic classifications already. Basically, what this shows that everything here before it looks like still early developments, and about this time the structure of the category structure of Wikipedia starts to crystallize. Of course, if you look carefully, you can see there is another change around 2008, but a lot of categories still are there. It was it's become more persistent at this moment, probably more regulated, because when category fundamental was basically emerged very early, so it wasn't clearly defined what is category fundamental. Recently it was even completely deleted because it was not clear what exactly is this. And at this moment, when category main topic classifications, then obviously you start to have more organized system. This is the same if we look at the assigned articles, so number of articles that unambiguously belong to given category. It's basically the same graph, except we have quite some part of ambiguous. There's also other part because yes.
What happened in 2009?
Here.
There are some changes.
Yes, there are changes basically in the beginning of 2008. There was again some reorganization within the categories in under main topic classifications. You can see it's also happening here, of course. But
data after 2008, or
no, when we started the project, the only dump for the Wikipedia, that's complete dump for the Wikipedia was from 2008. Only when we were quite advanced and already did a lot of things, a new dump was created. Because between 2008 and somewhere in 2010, basically there were no full dumps of the Wikipedia because the script that was creating those dumps in the Wikipedia just didn't work properly, probably because they were too large. Because the uncompressed dump that we used was about 3 terabytes. That was from 2008. And of course, later, the further it gets, it's the larger it is. Of course, this is the full dump. It means
What is dump?
That full dump. It's full, basically all the information, every single page in Wikipedia with every single revision ever made for this page. It's all information. So and it's XML file, which means it's very large. And every revision is basically a state of the page at this moment. So if you have small change to a large page, then you get just the same text all over with small change. For example, somebody changed the dot into a comma because it was correct, and you have all the text again. But that's how the Wikipedia has it recorded. So we don't do anything about that. But so we have dumped from 3rd January 2008. So we didn't have any data further on. But I expect that after this change, it will still again be sort of stable like this in this region. But that's only a guess. So after we know about how the categories evolved, right? We wanted to see how these categories, how this category structure corresponds to actual links in the Wikipedia, I mean page links. So we have thanks to our unambiguous assignment that we propagated down the hierarchized category structure, we decided that each article belongs to some or other top category, or were ambiguous. So basically, we had defined a groups of articles, so clusters, through the category tree. They were defined through the category tree, and we have looked at the modularity. Basically, this is the number of links sum over all clusters, the number of links inside the clusters minus expected number of links if the network was random. So it's between minus and plus 1. It's minus 1 if all the links are not in the clusters, are 1 if all the links are in clusters. Well, actually, 1 will leave is 1 cluster, but so if we now look at this category and the modularity, we could, for example, detect something new, something here with that the category structure didn't really change, but at least not when looking just at the category sizes, but because of some changes in either in the category structure or in the links between articles, the modularity, for example, increased from around 0, which means that these groups of articles on specific topic are not really related by direct links. So that people don't link to the feed to the area any better any more than to the outside. For example, if it was an article about physics, modularity around 0 means that there are lots of links to non-physics pages and some links to the physics pages, but the amount of links to the physics pages would be what you would expect if you just, because well, it's just there is certain amount of physics pages that you can link to. So if you chose the links, what pages to links at random, modularity 0 would mean that we just did it far. Of course, but generally we can still see that around here it is stable. I believe that this change was actually something in the category 3 because it would be unfeasible to think that there could be such a drastic change in the link behavior for articles on such short time step. So I believe here, despite the sizes of the different articles, the different top categories remain about the same. Different articles actually fall under them, and what falls into the articles after this moment is more correct in a sense that it creates clusters that are actually more related to each other than the previous category structure. Well, and that's the last part. I was mentioning the UDC in the beginning, and that we're comparing this Wikipedia with the UDC.
Sorry, this is the Dublin code. What does UDC mean?
Universal Decimal Classification. Universal Decimal Classifications has 10 main classes, which that's why it's decimal, because it has up to 10 classes on each letter, designated by a single number, a single digit. And we have looked into basically this outer ring shows the distribution of the number of records inside the universal decimal classification. But these are not really, these are records which means these are like like if they were categories, because these are only the numbers that you could assign, because we looked into a so-called master reference file for UDC, which lists a lot of different classes and subclasses and so on, which helps, for example, libraries to classify actual books, for example, it shows where the classes where you put the book. And the interior is the Wikipedia, also categories, because now these are weighted by the number of articles by fractional assignment.
The size of the UDC is decided by what, the number of files, books,
no. These sizes it depends on the number of records in the master reference file, so like a number of classes that exist within the certain main class of the UDC. Main class 10. The UDC has 10 main class. Well, 9 because one is unused. 10 main classes. 0, which is information, science, and things like that. 2, which is psychology and philosophy, basically. 3, which is religion. 4, which is business. Basically, these are names of the Wikipedia classes. After 3, 4 doesn't exist. 5 is natural science. 6 is engineering sciences and life sciences. Then it's sports and entertainment. It's culture and literature and geography. And
so when you set reference to the science of astronomy, physics, mathematics, chemistry. So you have the third one is science. And
Yes.
then,
Okay. Well, and now we have this is 2008. We have a number of categories in Wikipedia, and we have mapped the Wikipedia categories into UDC main classes based on basically we looked at the names of the categories in Wikipedia and the text for the UDC classes and its subclasses, and did some comparison between the two to find it, and then had to apply some logic also, logic or just.
Why UDC overemphasizes so much technology, all the technical things?
Sorry?
I mean, half of UDC is technical things.
Yes.
Why it overemphasizes so much that? It's a problem.
Okay, why it is a life sciences engineering. It's basically that's why is that. If maybe I don't have a slide right now, but if we look at the UDC when it was created in 1908 or something or something like that, it was a lot more balanced, but it was evolving over time. The UDC consortium was changing it to adjust to the needs, and which shows that UDC is mostly a lot more used to fine-grained describe the scientific content and not the popular content. Probably because popular content libraries don't think that popular content has to be so fine-grained classified. For them, it doesn't matter if it's that kind of film genre or different film genre or a book genre, or even genre maybe yes, but after that, okay, it's something.
There is also a big difference in the size of the UDC and the Wikipedia, or the number of articles.
Sorry?
Which is the difference in the size of the two databases? The UDC is much similar, or is much smaller?
For the UDC, original UDC, it's much more evenly distributed. Okay, but if you look at the Wikipedia, you see that in Wikipedia, what we could see also earlier, a lot more falls in there. Basically, it's the largest group of categories is in entertainment, and also in culture and geography. And the blue ones, basically category people fell, and we assigned category people into zero, which is general about science, information theory, computing, and things like that. Because basically when we looked at these names of the categories and descriptions of the categories in classes in class 0, it was the best fit to put it there. And so it's this mapping between it's also not really clear. It had by necessity it had to be. In the end, somebody actually, it was mostly Anila, the art historian, who actually decided where in the end it should, what would be the equivalent, which category, which class each category belongs to. Okay, but that's just one of the things. We also made some kind of map which is not very visible here, but it's just to show which shows the UDC and the first four layers of the Wikipedia category, of the 4 layers, because it was enough already. But they are not really that much similar. This was actually we created this for a submission for places and spaces exposition for the but it evolved since this form later. Yeah, basically this is one page. Thank you very much.
Thank you, Krzysztof. Questions?
Yeah, what are more or less the conclusions of the project?
That's the hard part. I mean, because basically we run out of time within the project. So the conclusion part is hard for me, especially for me to make, because the subject was not really physics, and
so if the conclusion is not clear, what was the question?
the question was what is the structure of knowledge? But as you can understand, it's a very broad question.
Do you address the question, what's the structure of knowledge? Because as I understood, the original motivation was that you say UNIC is a man-made structure.
Yes.
Let's say top-down approach.
Yes.
While Wikipedia was, and may have misunderstood it, example of self-organized.
Yes.
But as I saw, it's not self-organized at all, because you have these major cuts where a consortium of people seems to reorganize the categories and fit them into a structure that they think is appropriate at the time. But it's not anymore done by the users who create categories and they self-organize.
It is still done by the users. It's just that yes, at the very top it is being more and more regulated.
So at the end you have people again who then said at this moment I think that structure is the right one, so it's not self-organized. Because you showed this major cut at a certain moment.
Yes, it's not.
Who defined the new structure system or category system at that time?
Nobody really defined it. It's, well, we don't know exactly who was that, but during this, when they introduced main topic classifications, basically they moved existing categories under that. So it was just reorganized because this graph shows very well the changes at the very top of organization, but below these classes there is a whole huge category structure that is a lot less regulated, because people can't follow several hundred thousand categories.
What you're saying is the top levels are more or less organized by
consortium,
but lower levels are self-organized.
Yes, but as I say that this. At the beginning, at least it's a lot more self-organized. Only after a while, it starts to be more regulated. But it still evolved. It was just sort of evolved structure pressed into this kind of scheme. But what we looked at the direct links between articles. When we look at the direct links between articles. Then no living person can look at several tens of millions of links at once. So this is called self-organized.
Did you, for example, contact them to find out what happened at this jump from 0 to 0.1?
No, we didn't.
Whether there was a major cleanup that they did, or was it?
Sorry, I don't know, because this was one of the last results.
But that's interesting, because even random graphs can have these kind of values. So I mean, for modularity, this value is slow, and if you have a random graph do some partitioning, and you get very these kind of values in the modularity, so it's essential. Careful with this. It's true that we have the same error a long time, so that's okay.
I wouldn't expect it to be very good because first people actually do link to articles outside the field. I mean, and especially if you consider in a physics article, some things a physicist who is writing that would consider obvious, so it would link to energy, for example, sometimes, while he would link to some concept that is for him different, and which would fall some especially, for example, if that was article about applications of some physical phenomena in medicine, that would be all the things in this section would be linked to articles in medicine, because they are obviously needed there. So the fact that the linking is still within this, it's mostly within these clusters. It's still some information.
My question has been answered.
Okay.
So I suppose that you did that in English, right?
Sorry?
For the Wikipedia in English.
Yes, that was the English Wikipedia.
But as far as I know, I mean, the categories are different depending on the language. So German categories, French categories are different. So the question is, what if you do it? I mean, the categories in different languages are different. What this is telling you about the structure of knowledge?
Some language is part of the knowledge.
We didn't even have time to do some things we still wanted to do here. So we didn't even try to look into different languages. But you have to remember that not only category structure will be different in different languages, but also the articles will be different.
Yeah, then what is the use of something that depends on the language is telling you about how knowledge is organized? So is language dependent, depends on the language, depends on the culture, and it's not universal for...
That's a good question.
I don't think that scientific language should be independent. Scientific knowledge should be independent of language. But all types of knowledge do depend on language.
Yeah, but actually scientific knowledge is only a small part of the Wikipedia. Most of it is not scientific.
Really?
That was actually my question. I had a kind of maybe a general comment. Do you make a distinction between knowledge of truth or reality, or as opposed to sociological knowledge? Or
my colleagues are very love that question. When we looked at the Wikipedia, we accepted that we just treat the we looked at not at any truth, we just looked at the knowledge of people, and we considered that Wikipedia is a fair representation of what people know in general, and not specifically what is the universal truth or something, because some of the things obviously are maybe they are wrong, but even if probably most of the Wikipedia content is true, but they are, for example, not relevant to most for example, for us scientists, what some music pop star life was, which is quite which I would say is probably the same size. This part is probably the same size like all the science in Wikipedia.
If I can make a general comment, maybe what's a suggestion for a conclusion, especially from this shot here. I mean, the very low modularity is a sign of the distance between the self-organizing system of Wikipedia, so the knowledge structure, and the tag system of category, in a sense. So maybe you should look at the category system as a separate system from the knowledge structure. coming from Wikipedia in this sense. That system of categories is a top-bottom approach, while Wikipedia knowledge structures come from bottom. So,
yes, but category structure was not really top-down. It was also evolved from the bottom up, and only later on it was sort of adapted at the top. Yes, yes, that's true. It was for sure influenced by the top-down thinking. But
another question: what about? I mean, for instance, you have the tree. So these categories are probably just in the top because the main categories are just the nodes below the first.
Yes.
Have you checked what happens with the statistics below each of them? If they are different in the sense of depth or in the sense of branching? Just to see if there is differences between the main categories. I mean, below the main categories, you have all the others.
Yes.
So hanging over them. But they end in a tree, so as I say, you have from each of them. Well, I mean,
it would be too easy if it was a tree.
Maybe it's a tree because you deleted anything that was in the tree.
It's a hierarchical graph.
It's hierarchical. It's not a tree. There are still 2 ways or more. That's why we have ambiguous categories that belong to.
No, yeah, but I mean the category level, not in the articles. To see if once, I mean, from the very top categories, these classes that we have here, the statistics are different in the sense of depth and in the sense of branching.
Yes, I understand. We actually did look into that a bit at one point, but we didn't find anything special. I mean, most of the, I think there was one category or 2 categories that were a bit shallower, but generally it was mostly the same.
So there are many interesting insights in what you said, but this thing here is one of the few type of quantitative analysis. And I mean, you look at this modularity, you subtract what would be a random network of links, and you get this thing. But as Jose said, I mean, can you compare that with any baseline result for modularity? I mean, those are 10% variations. I mean, are they meaningful or?
This is specifically because you get one random graph and make some modularity estimates, and you get a Gaussian. These values can be necessary.
Okay. Or could you can one look at this same quantity for the universal decimal classification in any way?
Not really, because universal decimal classification, we had only data about the structure of classification, so category structure. We don't have the equivalent of link structure. Actually, there were some data, but we didn't manage to do much about it, and it wouldn't be direct equivalent either. So we couldn't do that in UDC, but comparing with random things, I'm not sure, because I mean, at the beginning, there are some, of course, small secrets in this graph, because first there are ambiguous nodes. We don't belong to any community, so basically we just.
So you take them away?
No, I don't take them away. I just it's not one of the communities. It's just not one of the communities. So they don't influence it either positively or negatively, but they are still there and influence the total number of nodes here and the total number of links that are there. And there are quite, at least especially at the beginning, there is quite a number of articles that are not at all encompassed by the tree, because as I said, we looked at the topical category. Sometimes you could have something at the side that at least part of it was not completely not covered by the whole hierarchy, which at the beginning is at the very beginning it's everything, because there is no category, but later on it decreases a lot, but there is still a small part that is not covered at all, which makes it trickier.
Okay, I think if there is no any other urgent question.
And also there are not real pages, but like redirects that are well, basically we treat them as pages that are outside everything because they are usually not categorized.
Okay, then I think we can stop here. Thanks, Krzysztof.